Did you have a nice fall break? Yes, no, maybe so. Okay, so over fall break and everything, whoa, this is actually working now. Okay, over fall break and everything, we have graded your midterms, and your scores are on Blackboard, and I will hand out the exams. So we do have to just go through some lecture today, so I'm going to go through some lecture today, and then at the end of the class, I'm going to go over the solutions. I'm going to hand you the exams back and also your cheat sheet. I'm going to hand all that back so you can take a look while we're going over the solutions. Let me go ahead and open up Piazza. On Piazza, I posted the stats for those that are curious, like what was average or whatever. This is the average for both sections. Very similar. Average is actually very similar across both sections. This class, your median was a little higher, so that's great. Standard deviations, so the only reason I put that is because just to let you know that average isn't always accurate, right? That doesn't mean everybody got an 80. Standard deviation tells you how far across, kind of gives you an idea of how distributed the grades are. And in programming classes, it's typical to have a high standard deviation, maybe unfortunately or fortunately, because a lot of times it's very binary. It's either you know it or you don't. So it's a lot of students tend to get really high scores or really low scores. Unfortunately, that's how a lot of it turns out to be. However, in our class, I gave a lot of partial credit and a lot of notes, a lot of little notes or little partial credit here and there for everything. So we try to even out as much as possible. So I will give it out to you at the end of the class, and if you have questions, I'll stick around to answer any questions about that. So this is the highest average I've ever seen. I've taught this class for 4 semesters now. Usually the average has always been around 77, 76, 75, I think was the lowest, and then 78. So really good job. Some of you asked, is there a curve in this class? Well, if I were to apply a curve in this test, I would curve down, right? Because this is a pretty high average. If I want to curve, I would curve on a 75 or something, right? So I typically don't ever curve unless the average is really low, below 70, and this is definitely not the case. I try to be I think curves are kind of unfair, honestly. I try to be as raw score as possible, as objective as possible. So even in your grade, whatever you see in your weighted total column right now, that is your current grade. There is no, I'm not going to curve that grade at any point. Whatever you see on the weighted total is your current grade as of right now. But don't be discouraged if you're not happy with whatever your grade is right now. Don't be discouraged. But I think most people are doing really well in this class. I don't think there's any Fs. So, yeah, I mean, not even Ds. Maybe one C, or maybe a handful of Cs, not even. But most of you are B or above, so that's really good. I know you guys all want to get A's, but A's are really hard in college, right? So if you're getting a B in this class or above, I mean, I consider doing very well in this class. What was I going to say? So grades, yes. So this is a good time to kind of review your current grade. I think the drop deadline is coming up, so if you're thinking about dropping or something or not dropping, this is a good time to kind of review your grade and see what you have left. Don't forget that we have, this is not the last chance kind of thing. You have several more things that will impact your grade. So that if you go to the syllabus, you can kind of remind yourself on everything. So we have another midterm exam coming up. It's in week 12. I think it's November 14th or something like that. And that's worth the exact same as this midterm. So both midterms combined are going to be 25% of your grade. So the second midterm does impact your grade, so keep that in mind. We're going to have a few more assignments, so assignments are still going. We're going to have a few more labs, so labs are still going. And then the big chunk of your grade, and this really impacts a lot of grades, is the final project. It's worth 30%, so it's quite a big chunk. And the reason why this is 30% is because ultimately in this class, the goal is that you create a web application. So the final project is creating a web application. If you can build it, that means you know all the material in this class, and then that's the grade you deserve in this class. So this is a huge impactor, so just keep that in mind. If you're kind of concerned about your grade right now, the final project may be able to really bring up your grade. If you want to talk specifics about your grade, like if we want to like run a report and see how a very detail on what your grade might look like in the next, we have like 7 weeks left. Feel free to come talk to me during office hours. We can talk privately, or if you want to make an appointment with me, we can, or with me you can. So there's still a lot of chances, but this is a very good halfway road if you want to kind of evaluate and think about your current grade in this class. Okay, so we'll do more midterm stuff again after today's lecture. Okay, so we're going to continue down the back end, and we are at week 9, and we're going to go back to our typical labs on Wednesdays, assignments due on Sundays. And we are going to continue to work with databases this week, and the next week we're going to start talking about PHP, and we're going to kind of bring everything together, like HTML, CSS, PHP, and database. We're going to bring everything together next week. So for the next few weeks or so, we're going to be bear with me, and let's continue to go strong, or let's end the semester strong. Let's continue to knock out labs and assignments for the next few weeks. And in week 12, we have the midterm. And then after week 12, after the midterm, it's mostly going to be, the assignments are all going to be based around you're working on your final project. So you're going to have about like 4 weeks to work on your final project. So we're that's kind of where we're headed. We're going to close out the back-end section the next few weeks. We're going to take the second midterm, and then we're going to work on the final project the last 3 or 4 weeks of the semester. All right, so let's continue talking about SQL today. So if you can, let's take care of a few things first. If you can please open up the click on the lecture notes for today. There's a few things we got to take care of. First of all, download the SQL file. Okay, just download it. We're only using this to populate our database, so honestly, it doesn't matter where you download it. Maybe I'll just throw it in here. Okay, just kind of throw it in somewhere. Oh, don't forget to do your attendance if you haven't done it yet. Okay. All right, and now that we kind of learned about how databases are designed, what a diagram looks like, now we're going to write something called SQL. We're going to be writing some commands to interact with our database. So to do that, we're going to need instead of using the simple film database or the restaurant database, we're going to be using a pretty robust database so that we can do all kinds of interesting things with this. So we're going to go ahead and create a brand new database. So if you can also, after you download the SQL file, also go to cPanel again, and we're going to create some more databases, or one more database today. Yes, it's 303.itpwebdev.com/cPanel. Okay, and then you log in with your FileZilla password or the password you used last time, the cPanel password. And we're going to scroll down to where it says databases and click on MySQL databases. And we're going to create another database. Last time we created the restaurant database, and then for your lab you created the film database. We're going to go ahead and create one more database here, and we're going to call it Song Database. And it's going to have all of the song information that we're going to import in. And let's give it a second. We're all logging in right now to the same server, so it's going to be a little slow. All right, cool. Create a new database, so let's just call this SongDB. And as usual, it's going to prefix our username here. So we'll go and click on Create, go back. And there we are. Where is it? There we are, right over here. I just created a brand new database. It says 0 bytes because I haven't done anything with it yet. And then down here, if I keep scrolling down, let's go ahead and add a user to this database as well. We haven't done much with the user just yet, but for now, let's go ahead and add it in. My database, not SongDB, right here, and there's my DB user. Okay, there you go. Now let's click Add. And then let's give them all privileges. So same thing as what we've done before. And then go back, and then now, back in your MySQL databases, you should see, if you scroll down somewhere around here, you should see the Song database with your username prefixed on it. And you should see that a user is assigned to this specific database. And then it's still empty because we didn't do anything with it yet. Yeah, the same user that you created last time. Yeah, just add it. We're only going to work with one user. If you missed any of this instruction one more time, go to the cpanel 303.itpwebdev.com/cpanel. Go ahead and log in. Scroll down to where it says databases. Click on MySQL databases. And then here, we're going to create a brand new database, just like that. And it should show up right on the bottom. And then you want to make sure you add a user. And that's kind of it at this point. Anybody having issues? Alrighty. Okay. After you've created this database, we're going to go ahead and populate the database. We're going to import in a database in here. We're not going to go and create we're not going to design a database all over again. We're just going to use a database that's already exists. So I'm going to go back to the cPanel, the home of the cPanel. Scroll down and let's click on phpMyAdmin. Okay, for your lab, you probably looked at phpMyAdmin to double check that your database is working. phpMyAdmin is just another piece of software that helps you visualize databases very nicely. The only difference between MySQL Workbench and phpMyAdmin is that phpMyAdmin is installed directly onto the server. That's why you have to go to a specific address and all that stuff. Versus MySQL Workbench is installed on your computer, right? So it's installed on your computer and we're connecting to the database. Versus phpMyAdmin, this is installed directly onto the web server. So it's a little bit, it feels like it's a website almost, and and it's easy to use. phpMyAdmin is a tool that a lot of database administrators or anybody that uses databases use. It's actually very easy to use, very convenient. So let's click, okay, on phpMyAdmin on the left here, you should see your SongDB. Make sure you click on it. And if you click on the SongDB, you're going to see that it's currently empty. Let's give it a second. Yeah, there's like 60 of us logging in at once. This is probably not a good idea to do. But yeah, it says no tables found in database, right? So we don't have any table, no records, no columns, no nothing. In my Song database, I'm going to go ahead and import the database I just have given you. Click on import on the top there, import. Make sure you click the SongDB first, and then click on import. Let's give it a second. Okay, after you click on import, click on choose file, and then that SQL file you just downloaded, the song.sql, that SQL file, we're going to open it, and let's go ahead and click go, and let it run. It's going to run a bunch of SQL commands, and then eventually the database will get populated. Kyle, real quick, can you help this gentleman out? Thank you. All right, there you go. Yeah, give it a few minutes. Give it like a few seconds. I think it just, again, there's 60 of us all connecting to the same ITPwebdev.com server, and so it's just taking some time. Hopefully you see this success message. Okay, so again, if you missed any of those steps, I went to phpMyAdmin, clicked on SongDB, I clicked on import, and then imported that SQL file. If I now click on SongDB, give it a second, but on the left, you're going to see there we have all these tables now. Yep, click go. That's all you do. You choose the file, click go, and then give it a minute. There's a lot of us doing this all at once, so yeah, maybe this is not a good idea. Bless you. Okay, and eventually, if you are able to get the import working, you should see the SongDB. You should see all these tables here. Okay, and this is the diagram of that database. Okay, I'll give you a couple minutes to make sure this gets imported in. Yep, or all the tables, yep. Yeah, you just wait.
Wait, can you wait though?
Yeah, you can wait.
Wait, can you wait?
Oh, yeah, I'm waiting. Yeah, I'm waiting. Yeah, I'm waiting. Meanwhile, if you haven't done attendance, make sure you do attendance. You have a minute left.
No, I can show it to you. I'm not like hiding anything.
Alrighty, while you're waiting, while it's going, let me go through what SQL is first, and then we'll actually write SQL when everything's loads. Okay. All right, if I could have your attention, please. Structured. So SQL or SQL, we like to also say it, is short for Structured Query Language (SQL). So sometimes people call it SQL. Some people just call it SQL, more recently I heard somebody call it squirrel, which is not correct, but it's kind of fun. Yeah, yeah. I was like, what? I thought squirrel it was like a new language or something. You know what I mean? Because people like come up with new languages all the time. So my thought was, oh, is that a new language? But they were just talking about SQL or SQL. It is used by most databases, so like your enterprise level databases like Oracle, and then your more open source databases like MySQL or Microsoft SQL Server, etc. A lot of them use this SQL language, and they use this language to interact with your database, with the database. Every version or every database uses a slightly different flavor of SQL, so you got to be a little bit careful in that case. But most of the time, in general, and there's some, of course, like Oracle is a huge company, right? So they can also have their own proprietary tools and things like that. But generally, like the standard things are all the same across all the different types of databases, relational databases, I should add. Remember we talked about NoSQL databases, like non-relational databases. Of course, they obviously don't use SQL. Nice thing to know about SQL is that it's case insensitive, meaning it doesn't care about capital letters or lowercase. It's all the same to them. However, just good practice is to in SQL we have a lot of keywords or commands is another way to call them. We typically capitalize any of the keywords. So SQL looks something like this, and we're going to dive into this today. We're going to write some SQL scripts today, but they typically look something like this. They have these keywords, like as you can see, they're capitalized. Select from, right? Anything you see capitalized are keywords in SQL, and they do a specific command. And we're going to be going over these one by one. And with SQL, it's very important. These semicolons you see here are extremely important. Like in other languages, they don't, like JavaScript, for example. Actually, they're not as strict about semicolons. But in SQL, semicolons are very important because it directly says this is the end of my script. Okay, so using SQL, we're able to talk to a database. We're able to grab data from the database, like search is a very big one, right? If you have a huge database and you need to search for a specific thing, that's what SQL is very good at. You can edit, update, delete. You can edit things off the database using SQL. So what we're going to be working with is we're going to be working with a song database that you're maybe still importing. It is a pretty large database of songs, but I'll warn you, it's a pretty old song database, so you're not going to see any of the more modern songs, but it is a pretty large database with a lot of different tables. As you can see, there's a lot of different relationships and all that. But we're going to keep it simple. We're going to just work with these 1, 2, 3, 4, 5 tables here, and as you can see, this is how the relationships are mapped out. The main table is tracks. So any songs, we're going to refer to them as tracks. They're all stored in the tracks table. The primary key is like track ID here, as you can see. And there's like the name of the track, so on and so forth. And here's some foreign keys. For example, album ID. So each track belongs to an album of sorts. So one album can have many tracks, but a track has one album. Okay, let's continue down. There's media types. Media types is like, oh, here, I have this for you. Good, great. Media types is like MP, what kind of format is it? Is it like an MP4, so on and so forth? So the table is normalized so that this table, all it does is it just keeps track of the media types, and it's a one-to-many relationship with the tracks table. Genres, so there's a table with just genres, and there's a one-to-many relationship with that as well. The only thing that's a little odd, or might look a little odd to you, but this is just the way the database is designed, is that tracks don't have the tracks table is not keeping track of the artists. So in the tracks table, you're not going to see anything referring to the artist. So we don't know who the artist is that that wrote or that performed the song. Whoever designed this database, I actually don't know whoever designed the database decided, you know what, instead of mapping artists directly to songs, we're going to map artists to albums, right? And they're saying one artist can have many albums, but an album, album has many tracks. So this is the way they so if you want to ever find out who the artist is of a track, you have to kind of go through albums. A little bit strange, but we can still work with this. It feels strange, but I think I see where they're going. If they don't want to have individual artists on a song, like they want to map it to an album, and then the album has many songs. And one of the purpose of this database was to track who buys what songs and things like that. So I think that's the way it was designed. Okay. So let's. The first thing we're going to be talking about, we're going to be going through several of these SQL commands, and we're going to write them one by one, so we can get a good idea of how these commands work. The first thing in a database, so think of any website you go to, there's probably some kind of search functionality, right? You go to Yelp.com, you're going to search for some kind of food, maybe your zip code, maybe cuisine, right? You're going to do some kind of search. You're going to have to run through Yelp's database to find a specific thing that you want, right? Or whether you go to Google and then you want to search for a specific thing, you're going to have to search through Google's database. So that's the most common use case of a database. So we're going to be using 4 commands to typically run a search. The first command is select, and what select does is allow us to select specific columns I want to retrieve from the database. So something like this, and we can use commas to specify what columns I want to see, and then or we could just use asterisk to select just everything, blanket statement. Okay. And then the second one we're going to be using is from. From, this keyword is very important. From specifies what tables. So what table what table are you searching from? Are you searching from tracks, artists? We need to specify what table exactly. And you can select multiple tables by using commas as well. The third one we're going to use when we're searching is where. So we can actually add some conditions as well. Like, for example, when you're doing a search, right, you don't want to see all 100 or all 1,000 restaurants around USC. Maybe you want to kind of narrow it down. You want only the $1 sign restaurant versus $2 restaurant. So similar idea. We can use where to specify specific conditions. So kind of almost like we're filtering our search. Lastly, what we also use is something called order by, and we can use the order by keyword will allow us to filter or order our results by alphabetically, or least to greatest, or the other around, greatest to least. So these 4 commands, select, from, where, and order by, typically go together to complete to create a search query. That where condition has a lot of different operators you can use. You can do equal sign, not greater than, less, and so on. And so is null, is not null. There's a lot of different operators in the where clause. We'll go over that in a bit. And then, oh yes, and for strings, you want to use single quotes for strings versus using integers if you're looking for integers. And we'll take a look at this. So the best way to learn SQL, or honestly any kind of language, is you just got to do it. You just got to try it out. So let's go ahead and try this out. How's your SQL importing going? Has anybody still having issues importing there or anything like that? Everybody okay? Okay, hopefully it's imported by now. So let's kind of look at this one more time. So on my song database, I have all these tables, all these tracks. As you can kind of see, there's a lot of information here. Awesome. Now let's go ahead and write some SQL scripts to search for specific data. And as you can see, this database is pretty large. It has I think 3,000 songs in it or something. So it's we're going to be able to pretty much simulate like a typical big database and see what that looks like here. I think there's there's 3,500 total rows, I believe. Right? Okay, we're going to go ahead and open up MySQL Workbench to write some SQL scripts. And there's a lot of different tools you can write SQL with. There's MySQL Workbench. There's something called SQL Pro for Mac. Even in PHP My Admin, you can write SQL scripts in here too. But just because we just use MySQL Workbench, we're going to continue to use MySQL Workbench as well. I actually like using MySQL Workbench for SQL only because the editor is actually pretty nice. I think this is going to not resize, so okay. I changed to light mode, by the way, because dark mode and MySQL Workbench was making me go crazy. If you click on if you open up MySQL Workbench, the dolphin icon on the left here, you see ITP web dev that you saved from last week. If you click on it, you should be able to still connect. If you see this message, just say continue anyway, and then okay, whatever, I don't care about that. And it's going to open like a kind of like a blank piece of file here for you. Okay, and you can actually type in here. This is like a text editor. And in here, we're going to be writing some SQL. On the left here, you're going to see the administration tab and schema tab. Make sure you click on the schema tab here. And on the bottom, you can kind of readjust this. On the left here, there's a lot of different databases for me. But for you, you probably have like 2 or 3. Make sure you click on Song Database right over here. And what we're going to do is we're going to say set as default schema, like that, so that it's bolded. And we're going to be writing SQL. The reason we're doing this is because I'm going to be writing SQL against this database specifically. Okay, if you totally got lost, let me do this one more time. I opened up MySQL Workbench. Okay, brand new. Just opened it. And under MySQL connections, it should have saved from your lab over here. If you click on it, it's going to try to open the editor. It might give you a warning. Just say continue anyway. And then now we're in the editor, and there's like a place where you can type stuff. And then on the left, you see the schema tab. Click on the schema tab, and you see a bunch of your databases. You're going to click on the song, the one that we just imported in. We're going to right-click and click Set as Default Schema. So we're going to write SQL against this database, and that thing is bolded right now. Okay. To write comments in a SQL editor, it's -- comments. You could also do, I think /*. Yeah, for multiple lines. You can do that as well. Okay, I don't think you can't do //. Yeah, you can't do //. Either one. I'm just going to use single line ones for now. Okay, let's try writing some the most simple script here. We're going to go ahead and select everything from tracks table. Okay, so I just want to see everything. I want to search. I want to see everything from my tracks table. We're going to write select, and notice how it's capitalized. Okay, I'm going to write asterisks. It means just select all my columns. Okay, all my columns from tracks. Tracks is the name of the table. I like to have this diagram open. Where'd it go? On my lecture slides when I'm working with a database I haven't worked with before. So I know that this table is here. Tracks. By the way, if you if you find yourself in a developer position where you have to work with databases, this is a very typical workflow. Like they just give you a database. They go, here's the database, import it in. Oh, by the way, here's a diagram. So it's very typical for you to, as a developer, to kind of refer to a diagram a lot, and just have to kind of deal with the database you're given. All right. Okay. So let's go ahead and I have select * from tracks. I'm going to basically select everything from the tracks table. All right? And I want to run just this line right here, just line number 2. So when it comes to SQL, it's very different from like your other programming languages. SQL is not a programming language, so you're not going to be able to create functions or variables is kind of a weird thing, but like you're not going to be able to write loops. It's not like your typical programming language. SQL statements are more just like they are statements. So you're going to be writing a lot of statements like database do this, and that's kind of it. So a lot of times you only want to run like 1 or 2 lines sometimes. So anyway, we're going to go ahead and just run this one line here. And to do that, I'm going to click on the second Thunderbolt icon right here with the little eye on it, not the first one. What the first one does is it's going to run this entire page. But I don't want to do that. I just want to run one row at a time. So I'm going to click on this Thunderbolt icon with the eye. If I click on it, notice how on the bottom this panel shows up, and we get a bunch of results back. And these results, as you can see, we have track ID number 1. It's for those about to rock. There's the album ID, media type ID, genre ID. These are all foreign keys. There's a composer. We have milliseconds. We have the length, the size, and then we even have a unit price, like how much this track would cost. Kind of reminds you of the olden iTunes days, before streaming, before Spotify was a thing, when you actually paid per track. So it's kind of that model here. Okay. And so MySQL Workbench gives a limit. If you scroll down, if you're wondering like how many songs there are, MySQL Workbench, the Workbench, this tool, will typically give you only the first 1,000 results. So just watch out for that, I guess. Okay. And this little, on the very, very bottom here, I'm going to pull this up a little bit. On this bottom here, this actually will tell you if there's any errors as well. Right, so let's say like instead of select from, I forgot the S, right? Select from track. It's gonna notice this error right here on the bottom. It says error code. This table doesn't exist. So it's useful to have that open as well, just to know that to make sure you wrote the correct SQL statements. Yes.
How do you have the table's layout
The
again?
layout.
No, like the relationship between each table.
Yeah, so in this case, you can either,
Like the diagram?
yeah, so if in this case, you could always open up the model again, and then you could do like reverse engineer to see the diagram. So if you open up the model, you can. Or typically, I gave it to you. Usually, they just give you a relationship diagram. So I actually gave this to you in, this is today's lecture notes, lecture 13. If you scroll down, this is the relationship diagram here. Yeah, so I just gave it to you. To make your life a little easier. So as you can see, tracks table has like the name column, right? Album ID. It matches your diagram here. Perfect. Any problems with that so far? All right, let's go ahead and dive into this. Let's try some out. We're going to try this prompt here. Display tracks that cost more than 99 cents. Okay, and then we're going to add a little bit more here. Sort them from longest to, the other way around. From shortest to longest in length. Like the length of the song, or how many minutes the songs have. All right, so let's go ahead and type this out. So we're going to do select again because I'm doing more of a search query at this point. I'm going to select everything, and I'm going to select from my tracks table, right? The tracks table here. Great. Select from tracks. Okay, and this is where now that I have some more filters, I guess, this is where the where operator comes in handy. Right, so I want to still select from tracks, but I want to add some conditions where, right, it says where the cost is more than 99 cents. So if I kind of look over here, I know that the unit price for each of these songs are 99 cents, but I want it to be more than, I want to see the results. I want to see tracks that are worth more than 99 cents. So I'm going to go ahead and define this column here. I'm going to say, hey, unit price, right, that unit price, the column, it has to be greater than 99 cents. And then don't forget the semicolon at the end. Yes.
Can it all be on the same line?
Yeah, it could all be in the same line. Yep, this is fine. I just like to indent or make a new line every so often, so I can kind of see a little bit. But yes. Okay, and then let's click on that thunderbolt with the eye on it. Click on it, and then we should see. There we go. Now we see different songs, Battlestar Galactica, and we see like unit price 199 and above. Yeah, the first 1,000 results. Yes. Yes. Yeah, it moves the. This moves a lot. Hold on, let me. Yeah. Oh, maybe there's only 213. Oh, actually, no, you're right. Yeah, you're right. It says only 213 rows are returned. Oh, I guess there's only 213 songs that are worth more than 99 cents. Okay. Okay, let's add a little bit more here. Now what I want to do is I want to order by. Oh wait, yeah. Oh, I already have that. Okay. I want to sort them from shortest to longest in length, meaning how long the song is. Okay, so I'm going to add a little bit more extra filters in here. So that milliseconds column is telling us how long each song is, so we can take advantage of that, right? So these column names are pretty important. So I'm going to continue this command. I'm going to say order by. So order by allows us to sort things. Order by, I'm going to say milliseconds. There you go, milliseconds. Okay, and then it's going to, there we go. We go ahead and search that. And we have now, yeah, this is the shortest song. Shortest song that's worth more than 99 cents. It's like a trailer, I guess. And then it's going to go all the way from longest to shortest. If you want to go the opposite way, right, like instead of shortest to longest, I want to go longest to shortest. Like I want to reverse the order. There's a nice keyword for that as well. It's called descending, D-E-S-C. So by default, it's ascending from shortest to longest. That's the default. But if you want to go the other way around, you do descending. Oop, there you go. So this is the most longest song, and it goes to the shortest song. I want to add a little bit more information in here. So right now I'm showing like a bunch of columns, right? I'm showing the track ID, name, like album ID, all this information in this results right now, which is great. However, I can also kind of filter out my results a little even further. I can say like display only, let's say display only, what do I say here? Display only track ID, what else do I say? Name, price, and length. Name, price, and length. Okay, so I could do that. I could specify which columns to show as well. Okay, and that's that. Remember that select. That's the job of the select command. The select command allows us to choose which columns we want to see. So I'm going to go ahead and add that. I'm going to go ahead and make a new line here just to keep everything a little bit easier to read. I'm going to say, okay, I only want to track ID. So these are all column names, right? Column track ID. The name column, the price, where's my price, unit price, and the length. Okay, so I'm just kind of just taking the column names from here. If I didn't know what the column name was, I would refer to the diagram, right, to the diagram to be like, oh, what was the name of that again, right? So here we go. Okay, so now if I click on this thunderbolt here, with the eye, there you go. Now I still see the same results, the same records, but the columns, I see less columns. Oh my gosh. Okay, so I only say track ID, name, unit price, and milliseconds. So this is like a nice, if I wanted a simpler view, this is like a nice way to look at things. Any questions about that? Okay. Yeah. Oh, yes. Okay. Yeah. What is the difference between adding the asterisk or not? Great question. So if the select right now, if I specify certain columns, it'll only show those. So I said 4 columns, right? So it'll show only 1, 2, 3, 4 columns. But if I did star and I ran this, by the way, the keyboard shortcut is Command Enter. If I do star, it'll show all my columns from the table. Yeah, like all the columns, like media type, genre, all of them. Yeah. So yeah, it's useful when I don't need to see everything. I just want to see just the 3 columns. Okay. Right. One thing I want to point out before moving on to the next thing here. You'll notice that some values, like this one, for example, you might see null. Okay. So in the SQL world, in the database world, there's a difference between null and an empty string. Okay. It kind of depends on the style of whoever's designed the database, but typically, I've typically seen that when, let's say, this song doesn't have a composer, then they just null it out instead of leaving an empty string. People just typically null things out. So when it comes to working with null values, you can actually do something like this, like where let's say you want to only see composers that like display tracks with composer, right? Then I can just say where composer is not null, and then I'll see all the songs that have a composer. Does that make sense? Yes, in the front.
Is there like an ordering between like the statements? So like you have to always do where before order by.
You have to do where before like select or order by. Oh, order by.
So like a specified like ordering of where you put statements.
Yeah, let's try it out. That's a good question. Oh yeah. It has to be where and then order by. Yeah, that makes sense because you want to do your condition first and then filter your condition. Yeah. Question in the back. Oh yeah, Caitlin's gonna help you out. Awesome. Yes.
What's the difference between is not and the 2 brackets?
Oh, this is for is not null specifically. Like I guess you could do. You mean like this thing here?
Yeah.
I guess you could do that too. Let me just try it. Oh nope. I guess there's a difference between that. Yeah, that's a good question. But I guess when you're looking for null values, this is not a valid condition. So I guess you have to do is not null. Yeah. I think it's because this one, I think this is comparing numbers, but null is technically not a number. It's like its own data type. So
Cannot compare strings.
Good question. Let's try it out. I actually don't use this too much, so I guess it does do strings. I guess it could compare strings, and it could compare numbers, but maybe it can't compare the null type. That's my guess. Yeah, good question. Interesting. Yeah, I never thought. I just always use this, so I guess I didn't think of it that way. Yeah. Okay. All right, let's do a little bit more precise searches, like what if I? Oh yes. Question.
So when it says like with pattern, what type of pattern is that?
Yeah, I'm getting to that right now. Yeah, that's my next thing. Cool. So we got to do some of this stuff. Let's continue down this path. What if I want to do searches like this, where I'm like searching for a string, but like typical searches, like you're not looking for exact matches, but you're looking for like, the search query contains Frank Sinatra or something like that, right? So then we use a like operator to search for not exact matches, but like partial kind of similar matches. It's great for search patterns. So if you can't remember the exact name of something, you probably want to use a like operator. And we like to use wildcards, which is a percent sign here. So for example, it looks like this. Let's say you're looking for a song that has the word land in it, but you but you don't want to make it exact land. If you do land % like this, you'll be able to search for land, words that have land in the front, and then some other random things. So you can have like land, landmarks, landlord. With pattern like % land would be the other way around. So you have like island, highland, right? So it could be any other words and then land. You can do stuff like, you could actually put both percentage on both ends, and then you can look for any words that have a land anywhere. You could do it like that. And then you could also even do spaces if you want to look for a specific like word land. So there's several ways you can use a percentage sign to your liking.
Is there a way to do both, where you can search for patterns like land with a percentage sign next to it, like the word, and with a space?
Yeah. You can add multiple. We'll talk about it in a minute. Actually, we could do multiple where clauses like this. So we could have like where, this, and, or a bunch of these things here as well. So we can do also multiple where clauses. Let's say you have multiple conditions you want to fulfill. You can use or, you can use and. But we got to be careful when we're doing multiple, when we're mixing and matching, because order of operations does apply. One easy way to kind of remember is and. Think of and as like your multiplier, and then or as like a plus. What I mean by that is when back in your algebra days, when you learn like PEMDAS or PEDMAS, multiplication goes before addition, right? So and typically goes before or and takes precedence over or. So just kind of watch out when you're doing when you're adding multiple and or clauses. And you can always use parentheses to specify, okay, we're gonna do, this and is more important than the or, and so on and so forth. So just keep that in mind. All right, so let's try this out. Let's look for tracks that have the word you or they in their names. Okay, so let's go ahead and try this out. Let's go and continue down this track here. So display tracks that have you or they in their names. Okay, so let's start with the select statement again. Select asterisks. And from, again, tracks. So we're going to search the tracks table once more. And we are going to look, we're going to write where. Okay, where. Name. So name is the column name or name. And I noticed the bolded name, and in the morning section it came up, and I'm not sure why name is bolded. It's probably a reserved word or something, but it worked fine anyway. So where name. Name is like you, right? So the word has a word you in it. Okay. Or name is like it has a pattern day, or this word day in it. Okay, let's try running that. I'm going to go ahead and run it. And there we are. So, there we go. Display tracks that have the word you or they in their names. And now we have a different set of results. We have like, there's you learn, put you down, whatever. I'm looking for, there you go. King for a day, what a day, surprise. And then so there's your, like apostrophe in your honor, right? There's a lot of different yous and days as well. Okay, let's try it slightly. Let's try another one. Display tracks compose. We're going to add a little bit more condition here. One more condition here. Display tracks that are composed by you two, and that also have the word you or they in their names. Okay, so I'm going to write another one right here. Display. Tracks composed by you two that have you or they in their names. So we're going to do the same thing. We're just going to go grab all the tracks, all the columns where just sorry, one more time. Okay. Let's go ahead and type this out first. Name, like, day, the same thing. And then and composer, like. Oh, yeah. Sorry. Yeah. Yes. By the way, I hope you noticed like the case is insensitive. So earlier when we searched for U, we still see like capital Y O U and lowercase y o u. All right, let's see what happens if I search this though. Okay, so what am I looking for? I'm looking for songs that are composed by U2. However, something odd is happening. My composers they're not actually U2. This is all like a bunch of different composers. Okay, so what I'm looking for is not quite happening. Something is right? Something is not right. Oh, I do have some songs that are composed by U2, but it's like it has the word Sunday in it and New Year's Day, right? So something's off. So this is where when you see some weird results come up and it's not exactly what you thought it should be, check your order of operations. So I check your order here, because when you start to have multiple clauses like this, you got to make sure everything is in order. So what it's actually doing right now is it's kind of hard. What's interesting is this is what it's doing. It's doing name like. It's doing name like day. It's doing something like this. So this is taking this. They're kind of combining these two together, and then or this clause right here. So and always takes precedence. So it's actually looking for these two. So and we're looking for a bunch of tracks with the word you in it. So as you can kind of tell, like all these have the word you in it. And then we're looking for composer U2 with songs day in it. So this, even though we wrote this later, this clause is getting read first. So to kind of change that around, this is what I would do here. I would do word name instead of like this. I would do word name or like that and like that. So when you're writing SQL and you have multiple clauses, it's typically people like to use parentheses even if they don't need to, even though it's not required. People like to use parentheses just to make it easier for people to read. It's like, oh, okay, this makes sense. So we're going to look for songs that are always composed by U2, right? It's composed by U2, but they could have the name U or date in it. So let's go ahead and run this to make sure this actually works. Let's go ahead and run this, and there we go. We have, all of our songs are now composed by U2. That's great. And then it has the word U or date in it. So there's U, there's day, right? U, Sunday again, day, some days are better than others, so on and so forth. Any questions about that? Okay, so key thing to take away from here is when you're using multiple clauses, use parentheses so you make sure that what you're searching for is what you're searching for. All right, let's look at our song database again. All right, now so far we've been working extensively with just tracks, and we don't really care about artists or genre or anything like that right now. However, eventually I'm going to need to kind of access other tables as well, right? So, for example, if I want to, for my tracks, I want to know what artists are my tracks or my albums or what genre is this track. I need to. So far right now, if I want to look up this New Year's Day song, what genre it is, it tells me genre ID is 1, which is okay. But eventually, I need to know what genre ID 1 even is, right? I don't even know what genre ID 1 is unless I actually look it up. So the next thing I want to do when you're searching things, one more thing you want to talk about, or another concept that we have to talk about is join. There's a clause called join, and what join does is it allows us to join, literally, like, think of them, join tables so that we can get information from other tables. Yes?
Back into your SQL workbench.
Yeah. Oh, I just was done. There you go. Okay, so yeah, it works because it's not case sensitive. Yeah. Technically, I can write everything lowercase, but it's just nice to see the keywords capitalized just to differentiate. Yeah. Okay, so let's talk about this join clause. So join is used to combine records from multiple tables, and it's based on the relationships. And it looks something like this, and we'll try it out. But it's usually we're still going to use the select word to select columns, and then we need to specify which tables are we joining, are we combining together. The genre table and the tracks table, for example, we're going to join them together. This is kind of what it looks like. So we're going to be using like join and on keywords here. It's going to look something like this. We'll try some out. And the thing about join is the way that join works is it finds commonalities. It's saying, okay, what's the commonality between table A and B? And it's going to join on that level. So we'll take a look at that. This is a nice diagram to kind of help you visualize. There's also a concept called left join, which is useful as well. Just keep that in mind. In our today's example, we're going to be only using join, but left join is also useful when, let's say, I want to grab all my table A and plus the things that they have in common. So there's a difference between just join and left join. And if you're wondering if there's a right join, there's also a right join as well, but you don't really need right join. You can just do left join. Anyway, so there's a difference, slight difference between a join versus left join. But anyway, let's try it out. Let's try this. Oh, one more thing. When you're starting to merge tables together, though, there's bound to be some name conflicts. For example, let's say I'm going to join albums table and the tracks table. However, they both have the same column name. Both are album ID. Even though this is the primary key, this is the foreign key, they're both album ID. So this is going to be a bit of a problem, right? We have two tables with the same name. So sometimes we use, to avoid conflicts, we prefix them with table names, for example, like this. So and maybe you've seen this in other classes where instead of just saying album ID to select the column, we specify the table name. So we say tracks.album ID and then albums.album ID. So we kind of prefix the table name using dot to specify, oh, this, I'm talking about album ID from this table versus album ID from that table. So we're going to see this as well. Also, sometimes when we get back results, let's take a look at here. Sometimes column names are similar when we're merging tables together, and that could be kind of confusing as well. So sometimes we alias column names by using this keyword called as, and you can change any column names you want temporarily to whatever column name you'd like. Okay, so those three things. We're going to talk about join, we're going to talk about column naming conflicts, and then aliasing. Okay. So let's go back to our code here. As you can see here, we have tracks. Great, we have all these tracks. Awesome. But let's say I want to, what are we doing first here? I think we're going to, what I want to do is, great, we have all these tracks. But I want to go get, and I want to know what album, which track, or which album this track belongs to. Right now, all it tells me is, oh, this song, Who's Gonna Ride Your Wild Horses? What a weird song name, okay? What album ID, what album does this song belong to? What is album ID 232? I don't know what album ID 232 is. So what I'm going to do is I'm going to go and refer to let's go back to my track here, my tracks table. I'm going to join my albums table and tracks table and album table together so I can go ahead and grab this title. I want to know what that title is. The ID is not telling me anything right now, so I want to know what that column table is. So let's go ahead and do that. Let's go ahead and let's continue down our SQL path here. I'm going to say, where'd it go? Display all albums and artists corresponding to each album. And I can't spell display very well. Display all albums, let's. Okay, I guess there's one more thing we want to do. Only show album title and artist name. Okay, let's go ahead and start our select statement. For now, I'll come back and fix it later. I'm gonna just select everything for now, just keep my life a little bit easier. And what I'm gonna do is now, I'm gonna select from my track still, right? I still want all my track information. Okay, but we're gonna join my track with artists, artist, the S. Okay, all right. Okay, we're going to merge these two together, or join them together, but I also need to specify one condition. Where is it going to join? Like, what's the common intersection point? And in this case, what are we joining? So tracks and album ID is what is the foreign key here, and this is the primary key. This is how they're mapped together. I know that the diagram doesn't show it very well, but album ID is mapped to my album ID here. So that's their commonality. So I'm going to do it on, and this is artist ID, but this is a little bit weird because they both have artist ID. I'm sorry, not artist ID. What am I saying? Wait, hold on. I'm totally jumping ahead. Sorry. Select from. I'm not doing albums to tracks yet. I'm doing. Sorry, let me go back a little bit. I'm doing albums to artists. So I want to know which album. Yeah. Oh, I totally misspoke. Yeah. I want to show albums and artists. So which album is performed by which artist. Sorry, let me take that back. So I'm going to go ahead and join, select from albums. I'm going to join artists. Okay. And these, and so, yeah, oh my goodness. Let's go, I wanted to start small. So let me not jump the gun. All right. So we have albums, and each album has an artist ID. So we're going to join my albums and artists together right over here. Okay. And the commonality between them is artist ID. So, but then they both name their column artist ID like this. So we're gonna have to do something like this on albums.artist ID equals artist.artist ID. Okay, and let's go ahead and click on the Thunderbolt. And there we go. Now let's look at this. Yes, there you go. This is, I wanted to start small. So these are all my albums. Okay, these are all my albums, and this is the artist ID that was corresponding to each artist. But now I know exactly which artist is performed, or which artist has this album. So, okay, so for this album is AC/DC's album. This one is a Sept album. This one is Aerosmith's album, so on and so forth. And I want to only show the album title and artist name, so I can say like select title and select name, for example. Okay, now I can see only title and name. Okay, so now it's like, oh, now it's a very direct, like, oh, okay, so this one, big ones is Aerosmith, right? Like this Jagged Little Pill is Alanis Morissette, right, so on and so forth. Black Sabbath, right, so on and so forth. So we have successfully joined the albums table, which had a lot of albums and its corresponding artist. And then the artist is coming from this table. So we've merged these two tables, or joined these tables is the correct word, and then now we can see all the relationship or the mapping here. However, this column name title, column name name is a little like it's vague. So sometimes you want to change the column name when this especially happens like after you join tables. You want to label things correctly. So select title. I could do select title as album title, for example, and a name as so AS allows us to alias, so I could rename it temporarily to whatever I'd like. Name as maybe like artist name or something like that, and then voila. Now my columns are renamed. Instead of using aliases, now it's album title and artist name. This is just useful when you want to quickly kind of get a bunch of results, but you don't want all these vague names. Aliasing is great. Yes. Sorry, one more time?
Like name is a column from artist table.
Yes.
And then like we're selected from albums, like
we're selecting from album, the table albums.
Yeah, this one only exists. So title only exists in albums table. Yeah, and name only exists in artist table. Yeah.
And we're selecting from albums.
We're selecting from both now because we joined two tables together. Yeah, good question. So title is now that we joined albums table and artist table together, I have access to all these columns. I have access to name, title, artist ID, all these columns now. So yeah. So if I want to be more specific, I can say like albums. It's coming from albums. I can do that as well. If I want to be more specific.
John,
Mhm.
is it like the stage before normalization?
Kind of. It's like we're kind of going backwards. Yeah. I could join whatever tables I want as long as they have some kind of relationship. Yeah. Yeah, it feels like you're reverse normalizing. Yeah. Yep. Somebody else had a question, or we're good? Okay, this is the last join example we're gonna do, and this is probably the most complicated one you're gonna see. And then for your lab, you're doing very similar things. For your lab, I'm giving you some prompts, and you're simply writing some SQL scripts, and that's it. You don't have to upload a FileZilla or anything. Oh, by the way, this file can save. Let's go ahead and do that real quick. I can't believe it didn't save all this time. So this file that we're writing, you can save this as a SQL file, save script, file save, and then go ahead and save this like in wherever you usually save stuff. Let's call this like select statements or something. And it's notice how it's going to be a .SQL file. So this is a SQL file that you physically have or you have in your computer. So in your lab and your assignment, you're going to be uploading this SQL file to Blackboard. You don't need to upload it to FileZilla or anything because it's just a SQL script. It doesn't do anything really for the web at least. So I'm going to save this, and then great, it's saved. Okay, the last prompt I'm going to do is display all jazz tracks. Okay, let me go ahead and let's look at my tracks again. Okay, let's go ahead and look at my tracks. These are all my tracks. And I have all these genre IDs. Again, I have no idea what genre ID 1 even means. But notice how I have a column called genre ID. This is a foreign key. And it's going to map to genre ID. It maps to my genres table. It's a many-to-one relationship here. So genre ID 1 means something. I actually don't remember. So I'm going to go ahead and just select star from genres to do a quick search. Okay, and here we go. So my genres table has these records here. ID 1 is rock, ID 2 is jazz, great, and so on and so forth. 25 is opera, so on and so forth. We really like to have these primary keys. I just want to point this out. We really like to have these primary keys as integers because for the chance that what if this would never happen, but what if like some group of people decided, the word jazz is not a good name for this genre anymore. We're gonna change it to something else, jazzy. I don't know, something else, right? Then this name can still be updated, but the ID itself won't change. So that's why we love to use IDs when we're referring to records. So ID number 2 is always jazz, but if they change the name jazz to something else, ID 2 is still a viable ID and doesn't change your work. Yes?
Why, when you say like select all from
Mhm.
tracks, select all from genres,
Uh-huh.
you only select one thing?
Oh, okay. It's because I'm clicking on the Thunderbolt here, so it's only running this one line.
No, but I mean like, so when you say select, because like, doesn't the star mean that you select all?
I'm selecting all the columns.
Oh.
Yeah, and in the genres table, it only has 2 columns. Yeah, it's very, versus tracks has like a ton of columns. Yeah, it has a ton of columns. Yeah. Okay, so now that I know this, I know that genre ID 2 is, so genre ID equals 2 is jazz. Okay. So now that I know that, I can do a little bit more interesting things here. I'm going to erase this. All right, select from tracks. right? So I want to say, I'm going to go ahead and select my tracks where genre ID equals 2, right? So that's going to give me, let's go ahead and run this code here, or the script here. Now it's going to give me all my songs with just the genre ID 2, which is jazz. Great. But again, this is cool. That's all jazz songs. However, I don't know what genre ID 2 even means. If I want to display a specific name, jazz, I need to go back to my genre table and I need to grab that name column, right? I want to know what that exactly ID equals 2 even means. I want to display the genre name. So let's go ahead and, so my second part of this is I want to show track name, genre. I want to show the genre name. I want to show what else? The album title and artist. Okay. Album title and artist. So I want to actually display actual names, not integers, not the ID values. I want to show the actual name. Let's keep this one alone for now. Okay. So if I want to go grab my genre name, I need to join. This is where join happens. I need to join these two. So I'm going to select from tracks. I'm going to go ahead and join genres. Okay, so I'm joining these two tables here. I'm joining the genre table and the tracks table here. And I'm saying on. We like to indent just to keep this a little bit easier to read. And we're going to be joining on this ID here, this column here, ID. And it's going to be tracks.genre ID equals genres.genre ID. So genre ID column exists on both tables. That's why we're writing it twice. So there's genre ID here. This is the primary key that maps to my foreign key here, my genre ID. So the tracks and genres both have the column genre ID. That's why I needed to write specifically like tracks.genres. Yes?
Does it make a difference if we start with genres and with tracks?
Oh, like the order? No, it doesn't matter. Yeah. Okay. Yes? No. How the relationship formed is like you have to use you don't have to have the same name. Yeah. You do have to have it has to be the same data type but not the same name. Yeah. All right, let's try to run this and see what happens. Ooh, I get an error. Anybody have a guess on why I got an error here? Genre ID, right? Genre ID exists on both tables, here and here. So it's like, what are you talking about? Which genre are you talking about? In our case, actually doesn't quite matter because we either way, I want genre ID 2. I'll just go in the tracks.genre ID 2. And then now there we go. So I get all my tracks as usual. Oh my gosh, I hate the scrolling thing. Okay, all right. There's all these tracks as usual. But if you scroll to the right here, you're going to actually see genre ID 2. And there it is. There's jazz right over here. So I know it's all at the end, but there it is because I joined the two tables together. This is coming from the genres table. So each of them have jazz. So I can do something like this now. I can say select like track ID, tracks.name, like genre.name, something like that. Now if I specify like this, now I get an error. Genre with the S probably. Okay, now I have, wonderful. Now I can see that I have, I'm only looking at, the song name, and then this is the genre name, y'all jazz. Okay. But I also want to show a couple more things. We're almost out of time, so let's go ahead and quickly do this. I want to also see the album title and the artist name as well. Okay, and if you recall, let's go to our diagram here. Tracks also has album ID here, and this is a foreign key. It maps to my albums table. That's the primary key here. So I could join albums and tracks together as well. So I can get the album name. So I'm going to go ahead and continue down the line here. I'm going to do albums.title. Right? Is it albums? Yep, albums.title here. And then I'm going to say, okay, we're going to keep joining here. We're going to join albums. We're going to join albums as well on tracks.album ID. That's the ID that they share. And albums.genre, not genre, album ID. So we're joining, there we go. We're joining the albums table with my tracks table as well. And I totally misspelled stuff. Yeah, double checking my spelling here. Okay, and the last thing I want to show is artist name as well, right? So because I joined albums into tracks now, I have access to the artist ID now as well. So I could do another join. So I could join as many tables I want. So I'm doing join, what is that, artists. I'm going to do on. Okay, on, this one's a little bit different. It's albums.artist ID equals artist.artist ID. Okay, because we don't refer to tracks because tracks doesn't have a record of artists. So we're going to keep it like this. I totally misspelled stuff. Artists, albums, artists, tracks.genre ID equals 2. Okay, and then I probably want to also show my artist. Okay, I'm going to run it. I'll review it one more time with you. I just want to make sure it runs. I'm going to pull this up a little bit, and let me go ahead and just make sure this works. So I have, I'll come back to the code in a minute, but I have track ID, I have the track name, I have the genre name, I have the album title, and the artist name all in one nice table here. Let's look at let's look at the SQL again. What are we doing here? So my select statement tells me exactly which columns I want to show. So I'm showing track ID, I'm showing the name column from the tracks table, the name column from the genre table, and the title column from the album's title, and then the name column from the artist table. So these are all coming from different tables, right? 1, 2, 3, 4 different tables. All this data is coming from 4 different tables. And if I want to show all this data from 4 different tables, I have to join. That's why I joined like 3 times here, as you can see here. So my tracks, I started with tracks. I joined tracks and genres first, and then where did I join it from? I joined it at the intersection where the genre ID equal each other. And then I also joined at the albums table as well. And that's where the album and tracks meet the ID. And then lastly, I did the artist table, which in the artist table is related already to the albums table. So artists and albums are joined. And then lastly, my condition is, the only condition I have right now is where the genre is at 2. 2 meaning jazz. Oh, whoa, something weird happened there. There you go. That's the full statement. This is probably the most complex statement you're going to be writing in your lab, if any. Maybe you actually might not get to this till the assignment. But this is kind of a more complex one. But I just want to show you that, when you're working on a brand new web project, typically somebody is creating a database already for you. And based on what whoever designed the database, if you have to grab data from different tables and whatnot, this is probably what you're going to be using. You're going to be using select statements, you're going to be using from statements, you're going to be using join and where statements. All right, any questions? Okay, if you have still questions about it, don't forget to save. I'm happy to ask you about it. But more importantly, I think you're more interested in the exam. So let's take care of that.